In the southern constellation Pictor, 63 light-years from Earth, sits a young star that serves as a 23-million-year-old laboratory for the birth of planetary systems. This is Beta Pictoris. Its massive debris disk, seen edge-on, is one of the brightest ever observed, consisting of complex, overlapping layers of dust and gas. Recent observations have revealed the cat's tail, a 10-billion-mile curvy branch of dust, likely the lingering ghost of a massive collision that occurred just a century ago. But in July 2026, a new world was discovered, not as a point of light, but as a chemical fingerprint hidden deep within this luminous fog, Beta Pictoris d. The discovery was made possible by the synergy of space and ground-based observatories, starting with the James Webb Space Telescope's unique infrared eyes. Utilizing NIRSpec's integral field unit at a resolution of 2700, researchers isolated the planetary signal by ignoring the glare of the disk itself. By matching spectral templates to molecular absorption features, they read the atmospheric barcode of a giant planet, detecting methane, water vapor, and carbon monoxide. A radial velocity of 10 to 16 kilometers per second confirmed its position on the opposite side of the star from its famous sibling, Beta Pictoris b. This new world is a gas giant roughly 2.5 times the mass of Jupiter, with a relatively cool temperature of 600 Kelvin, similar to the planet 51 Eridani b. Orbiting at 30 astronomical units, it sits at the threshold of the massive debris disk, actively sculpting the sharp inner boundary of the system. Crucial confirmation came from a second team using the Very Large Telescope in Chile, led by researchers who searched for the planet's thermal signature in the L-band. They used ERIS, the Enhanced Resolution Imager and Spectrograph, which combines advanced adaptive optics with the precision of the SPI, FFIER, and NIX instruments. Remarkably, once the orbit was known, the planet was recovered in 11 years of archival data from VLT and Sphere. It had been hiding in plain sight since 2014. This is a historic shift in exoplanet detection, the first time a planet has been found by its chemistry inside a bright disk, without ever being seen as a separate point of light. This opens a new window for the next generation of extremely large telescopes to hunt for hidden worlds in the dustiest, most challenging environments in the cosmos. Beta Pictoris d reminds us that the most significant discoveries aren't always what we see, but what we can read between the lines of starlight.